A very powerful tool for analysing data is graphing. Although we can do this by hand, it is useful to use Excel. In this case, we can see time and distance for an accelerating object. We don't know for certain at this stage from the data that it is accelerating, but we gathered it and saw the object appearing to change speed. If I select these two columns by holding down Shift and selecting them, I can insert a graph. I can also click and drag, or alternatively click the first one, hold down Shift and click the last one. All these methods work. When I use a graph, I need to graph time against distance, an XY scatter graph. And because of a number of, and now we need to modify it slightly. The first thing we'll do is fix the title. Distance against time. We'll also add labels for the axes by using the insert. Now this is Excel for Mac, but most versions are quite similar. So on this one we have distance in meters, and on the x-axis we have time in seconds. I can't easily see all of the points, so I'm going to format those. I do that by clicking on them, then right-clicking and using Format Data Series. I'm going to move to here and edit the marker. I'm going to make it black for visibility, and I'm going to change the type of marker here with marker options to a built-in and a cross, and a little bit bigger to make it visible. I can now see the graph curving upwards. Now there are a few strange points here. This point here looks like it's below the curve, this one above, but I can't tell for certain whether this is a consistent acceleration. So I'm going to add a trend line. I'm going to right click again and add trend line. The linear trend line obviously does not fit. A logarithmic trend line doesn't work because I have 0 or negative values, and that has annoyed it. But I'll go back in. Because this looks like y equals x squared, I'm going to click polynomial of order 2, and I can see this trend line maps pretty well. I don't need to play with my forecast because I do have a 0 value, but if I, for example, started at 0.5 seconds, I might go, and I'm going to set the intercept to 0. I won't display the equation because I'm not convinced that it will be useful at this stage. Finally, we're almost complete with our graph, but because we want to analyze this in more detail, we need some better data points. So I'm going to right-click an axis, and I'm going to add minor grid lines. And I'll do the same for the y-axis. We can now see points down to about 0.1 second on the x-axis and about 0.4 meters on the y-axis. So we now have a very useful graph for our analysis.